All right, guys, so today we're going to take a look at parent functions. And our main focus is going to be on just three characteristics. So there are more than three characteristics. I'll be introducing those a little bit later, but we're just going to focus on three characteristics. Again, I want you to go ahead and split your screen. So remember to split your screen. You're going to hover on these boxes. These are going to appear, and you're going to click on that, and it's automatically going to split your screen for you. Now, I like this way. I like whatever my practice is on my left and my calculator on the right. So I'm just resizing my sheets here. If you come to the bottom left, you'll see a diagonal arrow, and you can size it horizontally and vertically at the same time. All right, so I'm just going to size that up real quick. You're going to Google Desmos graphing, and whatever state you're in, you're going to put that state. This will give you the calculator for the state that you're in. So I'm in Georgia, so I need to make sure that the calculator says Georgia. This way you're practicing with the calculator that you are going to get. All right, so let's take a look at this first parent function. We're given an equation, y equals x. I'm just going to type that in. So y equals x. All right, this equation is a straight line. All right, so I'm just going to hide, if you look at these two arrows right here, I'm just going to hide that so I can see the graph more. I can zoom out just to see the graph never changes. It's completely straight, and I'm at what, 500,000. You can click home, and it'll take you like to a view, that's a lot shorter. All right, so now once I'm there, this is what my graph looks like. I want to plot the graph, but it's kind of hard. Oh, I don't want to, sit here. I'm zooming in, by the way. I don't have to sit here and go 1, 1. A lot faster would be to make a table. So to make a table from a function that's already given, all you would need to do is hit settings, and you'll see that the function, as long as it's in y equals, a table will appear, but it must be in y equals for this table to appear. Click on the table, and we're going to fill this table out. We are going to see like our graph goes to -4, so I want to start at -4. If I want to add something in, I can just type over what's currently over there. So I'm going to type -4, my next one's -3, my next one's -2, and then I have up to +4. So I'm just going to come to the next line, go 3, enter 4. All right, so I have everything that's in this graph. So now I'm ready to graph. Also, you'll see as soon as I put that table in, you had these points up here. Now, I hate that they came in the same color in red, so I'm going to change that. I'm just going to copy this really quickly. Actually, no, I probably won't be able to. Yeah, anyway, it's in red. So if I click on the one with the equation, you'll see that goes away. If I click with the dots, you see those go away. The important thing to always realize is they line up perfectly. All right, so I'm going to put my table here. I'm only got 3 spaces, so I'll put 1 negative, 0, and 1 positive. So let's go ahead and put, all right, so when x is -3, the y value is also -3. All right, then we're going to put a 0, 1. When x is 0, the y value is 0. And then 1 positive 1, and let's see, the graph goes to 4, 4. So let's use the one that has 4, 4, 4. And you can see that that's there. So that way we get the maximum graph. All right, so this equation is called a linear function. Okay, it's called a linear function, and it's going to be one of the 3 main ones that we're going to focus in Algebra 1. All right, let's plot the coordinates, and remember, after I plot my coordinates, it should look like this. That's 0, 0. The 4, 1 is over here. That's 4, 4, and then -3. -3 is right there. So we're going to plot that. So it's -3 on the x. It's always x then y. -3 on the x, and then -3 on the y. 0, 0. And then 4, 4. 4 on the x, 4 on the y. Take a straight edge like a credit card, your school ID, something like that, and you're just going to draw a straight line. And because I don't have one, that's what that's going to look like. It goes on forever in both directions. Okay, so that is the parent function for linear. So let's do the next one. So the next one is y equals x squared. So you're going to type in y equals x, and then you can use this button right here, or you can do shift 6. Okay, so I'm going to do this button right here. Y equals x squared. It matches exactly. Again, I want to see the table for y equals x squared. So what do? We hit settings, then we hit table, and as soon as we do that, it appears here. But where's the graph? Oh my gosh. Anytime you want the computer to zoom into the graph, just click the home button, and there is the graph. So this this function looks like a U. All right, so this function is called a quadratic And the way to remember this is this U, right? All right, it looks like a U. It will also look like a U or an N. Sometimes it'll be flipped upside down. Let me show you what that is. If I put a negative right in front of it, you see it's flipped. All right, so it looks like a U or an N. Okay, and we're going to do that in a lot of detail a little bit later on. All right, so let's put in some points. Let's put one negative, so -2. -2 is with 4. 0 is with 0, and 2 is with 4. All right, let's go ahead and plot those points and making sure that our graph looks like the one on the right on the Desmos calculator. So you go x is -2, y is 4. X is 0, y is 0. X is 0, y is 0. I didn't move. X is 2, y is 4. Boom. All right, so there's my u. All right, so that is my quadratic function. All right, moving on to the next one. We're going to go ahead and put it in. 2 raised to the power of x. Again, this is the raise button right here, or you can do shift 6. So 2 raised to the power of x. All right, let's see what that looks like. Let's press home. I'm going to kind of hide this real quick so we can see. Someone said this earlier, and I want to go with their definition. It looks like a slide. Now, this slide looks like it's touching zeros, but this is interesting. Let me zoom in for you so you can see. It never actually touches 0. It gets very, very close to it. Like if I put it right here, you see that 0.0000001. All right, so even if I move as far left as you want to, 0.00001. Okay, so it never touches the actual 0. So this line, and if I zoom in here, you'll see that it starts to get away from it, right? Press home to come back to regular. All right, so this looks like a slide that never touches 0. This is called an isotope, but we'll deal with that a little bit later. Okay, so let's get our table so we can graph. So again, press settings, then press table. Okay, now you cannot graph decimals accurately. So what we're going to do is we're going to just graph the whole numbers. We do want a negative one, so we're going to kind of guess this one inaccurately. All right, so let's go with -1 and -1 and 0.5. Let's go with 0, 1. I like to have 0 there, and 1 positive. Do we have a 2, 4? 2, 4, we do. So 2, 4. All right, let's go with those ones. All right, let's go ahead and graph it. So we have -1 on the x, and then 0.5. So that's going to be halfway somewhere there. Then we have 0, then 1. So 0 on the x, 1 on the y. Then we have 2 on the x, 4 on the y. So 2 on the x, 4 on the y. All right, and then we're going to graph it, and you can see it's sliding and don't touch 0. So we're going to graph it sliding and don't touch 0. All right, it goes on forever in both directions. All right, this graph is called exponential. So this is an exponential graph. All right, so an exponential function. This one is called absolute value. And the way you remember that is because you're going to notice when you graph it, because of this V, you're going to understand what I'm talking about once you graph it. All right, then this one is called, all right, square root. All right, and then this one is called cube root. So when we're writing squared functions, we never put the 2 there. It's assumed that that's a 2. And then anything else than a square root, you have to actually put the number. So this one is cube, because cube means 3, root. Now, you're going to see that cube root and square root are very similar. So make that connection in your mind, because these parent functions, these 6 parent functions, you do need to know what they look like. All right, so once again, fill in the tables and the graph for me, all right, with the 1 negative, a 0, and 1 positive that exists on the graph. Let's practice.